In section 1.6 part B, we looked at expressions that had parentheses in them and needed to be simplified before we could combine similar terms. Question number 30 is -4 times 3x minus 2 minus 6x. And the instructions are to simplify the following expressions. Here I have a -4 in front of the parentheses. So I need to distribute the -4 across the sum 3x plus -2. -4 times 3x plus -4 times -2. I haven't done anything with this minus 6x yet, but I'm going to write it down at the end of the expression so I don't forget to deal with it later. Now, I can use the associative property of multiplication to rewrite this problem, or not. -4 times -2 is +8. Technically, I don't need to rewrite this in a reassociated fashion. I can use the property without rewriting it. In other words, I know that -4 times 3 is -12, and I could just have jumped straight to this step. Similarly, here I can rewrite this expression using the commutative property of addition so that all my terms with x in them come together. But technically, I don't need to rewrite them. I can jump straight to the next step, which says that since I have -12 x's and -16 x's, I have a total of -18 x's. And then this +8 gets added on at the end. There's no similar term I can add to the 8. So this is my final answer for this question. In question number 32, we have 7 minus 8 times 2a plus 3a. Again, I have a -8 that I can distribute across this sum, 2a plus 3a. This -8 times 2a looks like this, and -8 times 3a looks like this. But I have this 7 plus, this time at the beginning of the problem. I don't want to forget to apply that 7 plus at the end, so I'm writing it down even though I'm not using it or doing anything with it at the moment. Now I can simplify by reassociating the -8 with the 2 and the -8 with the 3. Whether I rewrite the problem, showing that I've reassociated those numbers, or not. Addition of a negative is the same as subtraction, so I can rewrite this as 7 minus 16a minus 24a. Now, 7 minus 16a minus 24a, these are both a's, so I have a total of a debt of 40 a's. I was down 16a before I started, and then I spent another 24 of my a's. So I have a total debt of 40 a's. This is my final answer. This is not the only way to do this problem. Let me show you another way. This is the same problem with all my previous notations erased. What I've noticed is that 2a and 3a are both terms with a's in them. So actually, I could combine these before I started. In fact, because they're inside parentheses, it could be argued that I should have done that to begin with. 2a plus 3a is 5a. Now all I need to do is use the associative property of addition to rewrite this problem as 7 plus negative 8 times 5 times a. And then I can do the arithmetic. 7 negative 8 times 5 is negative 40. Finally, I can write this plus a negative as a minus. And that's my final answer. And it's the same answer as I got doing this problem the other way. This is often the case in algebra. There are a lot of different ways you can approach a problem. One of them is not better than the other, as long as you're using what I call legal moves. When we did this problem before, we took the legal move of distributing negative 8 across 2a plus 3a. When we did the rest of our algebra, we ended up with the same answer. That's perfectly acceptable, as long as we get the right answer when we're done. In question number 39, I have 4x minus 7 minus 2x plus 5. I have two sets of parentheses. I know how to deal with the second set of parentheses. I know there's an invisible 1 here, and I know I can think of this minus as plus a negative. So I can distribute negative 1 across the sum 2x plus 5. But what about the 4x minus 7? Well, there's an invisible 1 in front of that as well. There's no negative sign here, but I can always write 1 times something because that doesn't change the value of the thing I'm multiplying 1 by. Here I had 4x minus 7. 1 times 4x minus 7 is still 4x minus 7. So when I distribute this 1, I get 1 times 4x minus, using that shortcut, 1 times 7. I'll do the rest of this problem in a minute. For now, let me reassociate these numbers. 1 times 4 is 4. And do this arithmetic. 1 times 7 is 7. Look, 4x minus 7. That's what we started with. So when you have an expression in parentheses, it's perfectly acceptable just to drop the parentheses if there's absolutely nothing in front of them. If there's a minus or a number or a variable, then you must do the distribution. But if there's nothing at all in front, then what's really there is this invisible 1. And when you multiply anything by 1, you get the same thing back. Okay, what about the rest of our problem? I said I was going to come back to this, to what I need to add to 4x plus 7. Here, I have to do distribution, even if all I'm doing is thinking of this as the opposite of 2x plus 5, then I end up with the opposite of 2x plus the opposite of 5. Now that I've got this far, though, let's think about this plus a negative as minus. And the same thing here. Plus negative 5 is minus 5. Finally, I can take the terms that are like each other and combine them. 4x's take away 2x's is 2x's. And if I start with a debt of $7 and I spend 5 more, then I have a total debt now of $12. This is my final answer. Question number 54. Here we have 2x minus y in parentheses minus 2 times x plus 3y in parentheses. I can use the fact that there's an invisible 1 here to rewrite this group as simply 2x minus y. If I distribute that 1 across the sum 2x minus y. I'll get 1 times 2x and 1 times negative y. For this piece, I need to think of this as plus negative 2 times, and then distribute the negative 2 across the sum x plus 3y. This plus sign can come down here, and then I have negative 2 times x and negative 2 times 3y. These already look pretty tidy. Let's rewrite 2x minus y. And then, since I can write addition of the opposite as minus, I can rewrite this term as just negative 2x. Here I have plus negative 2 times 3 is negative 6 times y. Again, I didn't write my reassociation, I just implied it. Finally, I have one more case of addition of the opposite. So I can rewrite the problem one more time as minus 6y. And finally, I can combine my similar terms. Here I have 2 x's. Over here, I'm going to take 2 x's away. That's 0 x's. Here I have a debt of 1y. Again, there's an invisible 1. And another debt of 6y, for a total of a debt of 7y. Now, I would accept this on an exam as correct, and you would get full credit. But technically, 0x, which means 0 times x, is 0. And 0 minus 7y is just negative 7y. So although I'll accept it, this answer is not completely simplified. This is my final answer for this question. And question number 58. Zero point 0.06x plus 0.04 times x plus 7,000. This problem has decimals in it instead of whole numbers, but we don't need to let that throw us. We're going to be applying the same principles. In other words, you might even think about trying this problem without really thinking too hard about what the numbers are, at least at first. Here's what I mean. Right now, all I know is that I've got a number times an x plus a number times parentheses. So I'm going to have to do distribution. Let's rewrite the problem with that distribution in mind. I'm copying down the first term so that I don't forget about it, but who cares what it looks like? For my next piece, I'm going to write 0.04 times x. And finally, since I'm distributing the 0.04, 0.04 times 7,000. I haven't actually done any of the arithmetic yet. That's what I'm going to do next. But something to consider is that this problem, if you get it this far, would get you at least partial credit. Here's a multiplication problem, 0.04 times 7,000. I can do this on my calculator, and I'll get 280. Here's a little mental math trick that I use. Just take the number part. Don't worry about the decimal. This 4 and this 7, their product is 28. But I'm not really multiplying 4 times 7. I'm multiplying something times 7,000. So I should really add 3 zeros on to the end of this. That takes care of the times 1,000 part of the problem. Over here, I'm not really multiplying by 4, but by 4 100ths. In other words, I should move my decimal point back 2 places. So the number I end up with is 280. Now let's turn our attention to the rest of this problem. Remember that 0.06 is another way of saying 6/100ths, or 6%. So what I've got here is 6% of an x, whatever an x is. And over here I've got 4% of an x. When I combine these, I have 10% of an x. This is my final answer for this problem. I'm not going to work this whole problem out, but I just want to make a point. In question number 56, we have 6 times 1/3 x plus 1/2 y minus 4 times x plus 3/4 y. Okay, this one has fractions in it. I don't need to worry about what the numbers are. It's the process that matters here. When I show my work, initially, what I'm going to be doing is showing distribution, whether I actually write these arrows or not, and then rewriting the problem as 6 times 1/3 x plus 6 times 1/2 y plus -4 times x plus -4 times 3/4 y. Now each one of these can be reassociated. 6 times 1/3 x plus 6 times 1/2 y. Plus a negative can be written as minus, and then I have plus -4 times 3/4 y. Now using the commutative property, I can rewrite this as 1/3 times 6 instead of 6 times 1/3. Many of these steps are not necessary in the strictest sense. My point in doing this problem is you shouldn't let the form the numbers come in throw you. Fractions are just numbers. Look, 1/3 times 6 means 1/3 of 6. What's 1/3 of 6? It's 2. What's 1/2 of 6? It's 3. Minus 4x. What's 3/4 of -4? Well, 1/4 of -4 would be -1. So 3/4 of -4 would be 3 times that. 3 times -1 is -3. Lastly, I know I said I wasn't going to do this problem all the way through, but it looks like I'm almost done anyway. So let's just go ahead and finish it up. Take 2 x's and spend 4 x's. Uh-oh, I've spent more than I have. Now take 3 y's and spend 3 y's. I don't have any y's left. As with previous problems, I would accept this on an exam, but 0y means 0 times y, and 0 times y is 0. So this is really like saying -2x plus 0. We don't need to write the plus 0. It's just -2x.